The view of the starry firmament at night is simply overwhelming, and anyone observing the thousands and thousands of twinkling objects over the coming months could be forgiven for thinking that the cosmos has been enriched by one more star. But this is not the case, as NASA has announced it will be the result of a brute natural spectacle that will once again show us the elemental forces of the universe. But what is it all about? Why will T Coronii Borealis shine 1,000 times brighter than before? Will the celestial body plunge its surroundings into disaster in a devastating explosion? Or is the breathtaking magic of space not always linked to chaos and destruction after all? Modern observatories in remote locations, highly complex telescopes, and an expert team of renowned astronomers. These are all things we don't need to marvel at the overwhelming transformation that T Coronii Borealis will soon undergo. In the constellation Northern Crown, around 2,700 light-years away from Earth, TCB will undergo a dazzlingly bright change that we can witness with the naked eye. Anyone with standard binoculars will be able to admire the star for just over a week before it disappears into the darkness of space again for the next 80 years. Strictly speaking, the term the star is not correct. We are actually looking at a stellar compound, a so-called symbiotic star, which is made up of an extended red giant and a compact white dwarf. A brief classification. Experts define red giants as aging stars of the size of a solar mass, in the core of which hydrogen burning has ceased due to a lack of replenishment. White dwarfs, in turn, embody the hot cores of red giants that remain when the outer shell is ejected in the final stage of the star's development. And that the double star dance in the case of TCB is anything but restrained becomes clear when we take a look at the distance between the two celestial bodies. This is estimated to be half an astronomical unit, half the average distance between the Sun and the Earth, or, in figures, around 75 million kilometers. It takes 228 days for the objects to orbit each other, and as a result of the spatial constellation, the matter of the red giant flows over to the white dwarf. Which brings us to the reason that will give us an awe-inspiring phenomenon in the night sky in the coming weeks. What makes T Coronii Borealis shine? As soon as the red giant has fed the accretion disk of the white dwarf to such an extent that a critical mass is reached, fusion processes begin, reflected in the form of explosive bursts of brightness. Such a process is known among star researchers as a nova. TCB undergoes so-called recurrent novae, which means nothing other than that the radiant spectacle repeats itself over time. This spectacle is based on thermonuclear self-ignition. In the course of material transfer, a disk of hydrogen and some helium collects on the significantly smaller white dwarf. Finally, the point comes at which the material ignites. However, this is not a fire in the sense of a classic fire, but a thermonuclear burning, in which hydrogen undergoes a fusion reaction. Indeed, the roots of the novae witness reports go back to the year 1217, and in combination with the observations recorded in the following centuries, the experts have determined that the nova eruptions of the binary star have an average period of 80.7 years. The last time this stellar floodlight was switched on was in February 1946. The next eruption is expected to occur again by September 2024. Apart from these events, TCB has an apparent brightness of 10.8 mag, which is, however, too faint to be visible to our terrestrial eye. However, the last two novae, in 1866 and 1946, had magnitudes of 2.0, meaning that the double star shone over 1,000 times brighter than before, even outshining Gemma, the otherwise brightest star in the Northern Crown constellation. As mentioned, the next nova is already waiting in the wings. And due to the 80-year rhythm, NASA speaks of a unique observation opportunity that no star enthusiast should miss out on. Consequently, a fundamental question arises at this point. How can the supposedly new star even be recognized in the sky? Well, the first step is to locate the constellation of the Northern Crown. This presents itself as a small semicircle of stars between the constellations Hercules and Ursa Major. And although it's generally an advantage to choose a dark location for nighttime sky observations, in the case of the nova, a slightly brighter sky could even be helpful. In reality, the apparently better visibility can make it more difficult to identify the object of desire in the overflowing richness of the firmament. But if you are in a bright place, you will only see the really bright objects that stand out behind the globe of the city. Rotating star charts or star chart apps are a practical way of keeping track of the current rising and setting times of the Northern Crown. When fed with the respective observation location and the corresponding time, the apps display current sky maps on which you can search for specific constellations. This star turns TCB into a puny firefly. The bottom line is that the universal rule seems to apply in the cosmos. You can always go bigger. In our everyday perception, the sun often embodies the cosmic ultimate, and in relation to our home system, this is true. But the further we delve into the gigantic expanses of space, the more our mighty host star blurs into an insignificant pinhead. If we place the gigantic source of heat and life next to the star Betelgeuse, for example, our central star has to admit defeat in all astronomical respects. Located in the constellation Orion, Betelgeuse has a diameter 800 times that of the Sun, that is, around 1.12 billion kilometers. In theory, our parent star would fit 500,000 times into the so-called shoulder star of Orion. The differences in luminosity are no less drastic. Betelgeuse shines 10,000 times brighter than the Sun. As a result, it's easily possible to spot the celestial body, which is around 720 light-years away from Earth, with the naked eye. If you are in the northern hemisphere during the winter months and look up at the starry sky, it's practically impossible to miss the red supergiant. And not just since yesterday. Betelgeuse was already mentioned in records dating back 2,000 years as a yellow-orange glowing dot in the firmament. Like all other objects in the universe, Betelgeuse is not a rigid, unchanging celestial body. The determination of its radius using interferometry revealed that it fluctuates by around 15%. Interesting to know, Betelgeuse's radius was the first to be determined using this measurement method. However, the stellar giant is also subject to recurring fluctuations in terms of luminosity. For example, a visible change in brightness occurs every 270 days. This recurring interplay is, in turn, due to the late stage of development that the star has now reached. In a nutshell, red supergiants have the characteristic of expanding and contracting again. The pulsation is also always linked to fluctuations in brightness. And just how drastic and puzzling these changes can sometimes be, scientists were able to witness firsthand a few years ago. Is Betelgeuse about to go supernova? Back then, in October 2019, the experts documented a strange process that ultimately led to a dramatic reduction in brightness. In February 2020, this was no longer even 40% of its average initial value. What's more, Betelgeuse had never been so dim since astronomical studies began. But what was behind the stellar dip in brightness? Well, some experts saw the loss of luminosity as nothing more than the result of several overlapping brightness cycles. Other researchers, however, feared that the development was based on something far more dramatic. Betelgeuse could be on the verge of a supernova. In principle, the explosive death of a star is heralded by the celestial body expanding greatly and undergoing a significant decrease in brightness. In the same breath, however, as no star has yet been observed immediately before a supernova, we do not know whether the corresponding dimming occurs several years or just a few hours before the explosive event. There is no doubt that one day Betelgeuse will indeed make an explosive exit. According to the current state of research, however, the red supergiant will only bid farewell to the cosmic stage in the distant future, as it only reached its final stage comparatively recently. The final supernova is likely to be a good 1.5 million years away. However, other experts have a much tighter time frame and assume that the colossus will disappear from the star charts within 100,000 years. After Betelgeuse returned to its former glory in April 2020, researchers were able to decipher the reasons behind the drastic drop in brightness. In August of the same year, observations by the Hubble Space Telescope revealed that the star had ejected a gigantic cloud of hot, dense material. This then cooled down, condensed into dust, and shielded the emitted starlight. Due to the cosmic dust veil, it only appeared from Earth as if the celestial body had dramatically lost its luminosity. Once an official explanation for the past development had been found, it didn't take long for the star to come up with another mystery. Since 2023, it has been shining much brighter than usual. But regardless of whether Betelgeuse will explode relatively soon or not for many hundreds of thousands of years, one thing is certain. As soon as the red supergiant transforms into a supernova, we will once again be impressively reminded of the elemental forces of the universe. As mentioned, Betelgeuse already shines 10,000 times brighter than the Sun, but in the course of its explosive stellar death, researchers expect a further 16,000-fold increase in luminosity. While some experts assume that the brightness of the star will then be comparable to that of the nightly crescent moon, others believe that it will match the luminosity of the full moon. Either way, this event would be unmissable from a terrestrial point of view. What is also unmissable from your earthly point of view is the subscription button. Become part of our community now and never miss an exciting video again.